Hi, today's video is going to be on transformation. So this might be a nice surprise because it's going to be a review of transformations. Remember, transformations and graph analysis are going to be those two ideas that we're going to use continuously through all of our stuff. So one thing that's important to remember is that the horizontal translation is happening inside of those parentheses. So when you see x minus 5 inside, that is really 5 units to the right. If you see a plus 2, it's 2 units to the left. When it's inside of the parentheses, it's going the opposite direction. If you have a vertical translation, it's the number being added, subtracted outside of the parentheses. So when you see the plus 1, that's up 1 unit. When you see the minus 4, that's down 4 units. A reflection is when you multiply, when that x or your variable is being multiplied by a negative. So a negative x to the fourth is a reflection over the x-axis. There are reflections over the y-axis that we're just not learning about, but we do want to specify that it's a reflection over the x-axis because there are different kinds of reflections. Then we have vertical stretches, which is also expansion, and shrinks, which is a compression. And that's going to be in the vertical direction. So when we are multiplying our x by a number, if the number is greater than 1, we are stretching it vertically by a factor, in this case 8. If your multiplier is between 0 and 1, then it's going to be a shrink or a compression in the vertical distance, in the vertical direction. All right, so let's go ahead and look at some equations here. We've done this already, but now we're just looking at all polynomials. So describe the transformations from f to g of x. And so in this case, we have f of x is x to the fifth power. That is, remember, the parent function because it has no transformation so far. Every time a number is introduced, it's created another transformation. We start with inside of the parentheses. And remember, inside the parentheses is a horizontal change, opposite of what we see. So the minus 3 means that we are going to be translate right 3. Then we look at the multiplier. We are multiplying by 2. That means that we have a vertical stretch because it's larger than 1 or expansion by 2. And then last, when we have a number being added, subtracted outside, that's a vertical shift. So we are going to translate up 1. So the same transformation rules. Now, instead of looking at any equation like we did in Unit 0, or in Unit 1 when we only concentrated on x squared, now we can have any polynomial. So it's still going to be x, but it can be raised to any exponent that we want. That makes it a polynomial. Write a rule that represents the indicated transformations. So this time, we are not starting at the parent function. I'm starting at x cubed minus 10x plus 9. The first thing we're going to do is a vertical stretch. And remember, this means that I take 2 and I multiply it by whatever function I'm currently at. I'm currently at x cubed minus 10x plus 9. So I have to multiply by 2 this entire equation. So we distribute that 2 to all of those pieces, giving us 2x cubed minus 20x plus 18. Translation left 2. Okay, so this is where it's going to be a little bit different because we know that horizontal shifts are happening inside of the parentheses. And if I'm going left 2, it's the opposite. So this is going to be x plus 2. But this is going to happen inside all of the x's. Before now, we only had one x in the equation. So now this becomes 2 times x plus 2 quantity cubed minus 20 times x plus 2 plus 18. So anytime you see an X, you have to represent that horizontal shift in all of those places. Followed by a reflection over the x-axis. So I'm going to take whatever I have and I'm going to distribute a negative. So this is where I'm at with my equation from the last step. I'm going to distribute a negative. And remember, it can't go inside of the parentheses because it's being trapped by the exponent. So our final equation is that positive 2 becomes a negative 2. The negative goes to that negative 20, making it a positive 20. And the positive 18 becomes a negative 18. Now, technically, in this equation, I could distribute the 20 to the x and the 2 because that's not being trapped by an exponent the way the first piece is. You can do that and it's going to be correct, or you can leave it here so that we can see the transformations. Either answer is going to be good. All right, one more. And actually, what I want you to do is I want you to push pause and I want you to try to see if you can do this one. There are fractions involved on this one, so don't freak out by the fractions. Leave it as improper fractions. And then when you're done, push play and see if you did it correctly. All right, let's see how you did. So our first transformation was a reflection over the x-axis, and we started off with this big equation not at the parent function. So I'm going to distribute my negative to everything so that positive becomes a negative, positive becomes a negative, negative becomes a positive, positive becomes a negative, negative becomes a positive. So I distribute that negative. Then I have a vertical shrink by 1/3. So I'm multiplying everything by 1/3. So I'm going to start where I left off and I'm going to distribute that negative 1/3. So that gives us a negative 1/3 x to the 4th. A negative 6 times 1/3, that's a negative 2. Positive 5/3, that becomes a negative 1. 1/3 times 7 is 7/3. So I distribute that 1/3 to each individual piece. And then our last one is a vertical shift up 5. So for this one, I'm just adding 5 to the outside of the equation. So I take where I left off in the last, and I just add 5 to the end. Then I have to combine these like terms because these are both constants. 7/3 plus 5 gives us 22/3. All right, so hopefully that was pretty good, a nice review of our transformations, and we're done with this video.